Hello everyone, and a very warm welcome to this exciting journey into the world of mathematics. Today, we're diving headfirst into the fascinating world of squares and square roots. We'll explore what they are, how they work, and why they're so important. These aren't just numbers, they're fundamental building blocks of mathematical understanding. They're keys to unlocking and understanding patterns all around us, from the simplest shapes to the most complex designs in nature and art. Don't worry, we'll keep things simple and straightforward, using real-life examples and engaging visuals to make everything crystal clear and help those aha moments really click. You might be surprised to learn that squares and square roots show up everywhere, from the arrangement of floor tiles under your feet to the grand designs of architecture all around you. By the end of our time together, you'll see maths in a whole new light, appreciating its beauty and its practical applications. We'll start right at the very beginning, with the basics, exploring what it truly means to square a number, and of course, how to find a square root using different methods. Think of this as a friendly chat between friends, not a high-pressure test or exam. We'll practice together with some examples, spot interesting patterns along the way, and build your confidence step by step, one concept at a time. So, let's forget any maths anxiety or worries you might have. Today is a fresh start, a clean slate for exploring the world of numbers. By the end of this session, you'll be able to confidently spot and use squares and square roots in your everyday life, from cooking to home improvement projects. Ready to begin this adventure? Let's jump right in and get started. Why learn about squares and square roots? Simple. They're everywhere in daily life. Need to figure out how much carpet to buy for a square room? That's a square calculation. These concepts are the foundation for geometry, algebra, and even computer programming. Mastering them sharpens your problem-solving skills and opens doors to more advanced maths. So what exactly is a square number? It's a fundamental concept in mathematics, and understanding it opens doors to more complex ideas. We're going to break it down in a way that's easy to grasp, so you can confidently identify and work with square numbers. At its core, it's just a number multiplied by itself. This means you take a number and multiply it by that very same number. No other numbers involved. It's a self-on-self multiplication, if you will. For example, 3 squared, which is how we often say it, is 3 times 3, which equals 9. That's the result of the multiplication. We write this in a shorthand way as 32 equals sine 9. This notation is super useful. The little 2 inches is called an exponent. It tells us to multiply the number by itself. It's a compact way of saying multiply this number by itself. 5 squared, that's 5 times 5, or 25. You're taking the number 5 and multiplying it by itself. Written as 52 equals sine 25. See how the exponent makes it nice and short? Square numbers can also be visualized, which makes them even easier to understand. 9 tiles arranged neatly make a perfect 3x3 square, and 25 tiles make a 5x5 square. The visual representation really helps solidify the concept. The first few square numbers are good to memorize. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Each of these comes from squaring a whole number. You can't get a square number by squaring a fraction or a decimal. Knowing these is as useful as knowing your times tables. They're that fundamental. They pop up everywhere in maths, from geometry to algebra. Get familiar with them. They'll make everything else easier. Trust me on this one. Square numbers are neat, tidy, and satisfying. They're a must-have tool in your maths toolkit, so make sure you understand them well. Now, let's flip things around and explore the fascinating world of square roots. Square roots are the inverse or the opposite of squaring a number. It's like going in reverse on a mathematical journey. If squaring is multiplying a number by itself, essentially raising it to the power of 2, it's a straightforward process. You take a number and duplicate it in multiplication. Square roots ask a very specific question. What number, when multiplied by itself, gives us this particular result? It's like a mathematical detective trying to find the hidden number. We're searching for the factor that, when paired with itself, produces the number we started with. For example, the square root of 9 is 3. This is a fundamental example that illustrates the concept perfectly, because 3x3 equals sine 9. It's a simple multiplication that confirms our square root. We use the radical sign, which looks like this. 9 equals sine 3. The radical sign is the symbol that tells us we're looking for the square root. Another example, 25 equals sine 5. This means that the square root of the number 25 is equal to 5. since 5x5 equals sine 25. Again, a straightforward multiplication verifies the square root. If you're unsure, break the number down into its prime factors, creating a factor tree, or recall your list of perfect square numbers. These are numbers that have whole number square roots. For example, 144 equal sine 12. This is a slightly larger number, but the principle remains the same. Because 12x12 equals sine 144. This confirms that 12 is indeed the square root of 144. Squaring and square roots are inverse operations. They are mathematical opposites. They undo each other, like addition and subtraction, or multiplication and division. Square a number, then immediately take the square root of the result, and you're back where you started with the original number. This inverse relationship is incredibly powerful and useful for solving more complex equations in algebra and beyond. For now, just enjoy the inherent symmetry and satisfying logic of square roots. Square roots are like solving a number puzzle, where you're trying to find the missing piece that fits perfectly. They're everywhere in the world around us once you start looking, from geometry to physics and even computer science. Let's try some examples together. 7 squared, 7x7 equals sine 49, 11 squared. 11x11 equals sine 121. Now, square roots. What's 64? 8x8 equals sine 64, so 64 equals sine 8, 100. 10x10 equals sine 100, so 100 equals sine 10. Your turn. Try these. What is 62? What is 132? What's 36? And what's 400? Pause and solve them. Ready for answers? 62 equals sine 36. 132 equals sine 169. 36 equals sine 6. 400 equals sine 20. Whether you got them all or not, practicing is how you improve. Don't worry about mistakes, just keep trying. The more you practice, the easier it gets. Maths is about building skills step by step. Each problem you solve makes you stronger. Keep challenging yourself with new examples. Practice is the key to mastery. Squares and square roots are everywhere in real life. Measuring area? A square patio 4 meters on each side covers 16 square meters. 42 equals sine 16. Buying a square rug with an area of 9 square meters? Each side is 9 equals sine 3 meters. Builders, designers, and even farmers use these calculations daily. Chessboards? An 8x8 grid is 82 equals sine 64 squares. These ideas go back thousands of years. Ancient Babylonians used them to build cities. From planning a room to playing games, squares and square roots are practical tools. Next time you see a grid or a tiled floor, spot the maths in action. These concepts connect us to history and everyday problem solving. Maths really is all around us. You've learned a lot about squares and square roots today. Now become a square detective. Find examples around your home or neighborhood. Measure a square object, square the side, and calculate its area. Share your discoveries and keep exploring. Next, try learning about cubes and cube roots for even more patterns. Check out resources like Khan Academy or BBC Bitesize for more practice. Remember, practice and curiosity are your best tools. Keep exploring. Maths is a lifelong adventure.